Okay, so a ratio is a quotient of two numbers. And let's say we have a ratio. It says the ratio of 5 meters to 3 meters can be written in the following ways. The order of the numbers when you write a ratio absolutely matters. So the way you're probably most familiar with seeing ratios is with the colon. So you could say 5:3. Whatever number comes first in the wording, that's what comes first when you're writing the ratio. Right. The most popular way for us to write a ratio is as a fraction. And whatever comes first in the wording is our numerator, and whatever comes second is our denominator. Sometimes you'll see the word 2, so 5:3. And the very last way, which we will very, very rarely use, probably never, is that baby division sign from elementary school, 5 divided by 3. I cannot stress this enough that the order you write the numbers absolutely matters. Whatever comes written first in the wording, that is the number that has to be in the numerator, or the first number written. All right, let's do a word problem. So a piece of a rope is divided in the ratio of 3:4. If the rope is 42 inches long, find the length of each piece. So what happens is we have a rope. This whole rope is 42 inches in length. But then something happened and we were going to divide the ratio. We were going to divide the rope into a ratio of 3:4. Remember, I've been stressing this since September anytime we have something like this. The minute you take numbers out of a ratio, what do you have to put with it? James? X. So we're going to say 3x and 4x. So we split this into the ratio of 3x to 4x. And now we have to solve. So we're going to say 3x plus 4x will equal 42. We're going to have 7x is equal to 42, so x will equal 6. So we want to find the length of each piece once we split it. So our 3x will be 18 inches, and our 4x will be 24 inches. Because ratios can be written as fractions, we always simplify fractions, which means we can always simplify ratios. So when they say express each ratio in simplest form, if I have 20 to 50, isn't that the same as 2 to 5? And now B, I have 54 to 36. I want to write that as a fraction. If I'm going to change 54:36 to a fraction, which one has to go in the numerator? The 54 over 36. Now we can simplify this. Let's say you thought of 9. So then you divide by 9. And then you will get 6 over 4. Is that simplified enough? No, you can simplify again. Divide by 2. When you divide by 2, you will get 3 over 2. Right, next one, 8 to 56. We have 8 over 56. We're going to divide top and bottom by 8, and we get 1 over 7. Okay, a proportion is an equation stating that two or more ratios are equal. To solve a proportion, we can cross multiply. Now we can check to see if a proportion is true, meaning if I have a half is equal to 5/10. This is a simple one because you can easily say, well, 5/10 is the same as a half, right? We can simplify that down. But another way to check a proportion to see if it's true is to cross multiply it. If you cross multiply it, you get 1 times 10 is 10, and then on the other side, you get 2 times 5 is 10. If the left side equals the right side, it's a true proportion. So for example, if you don't have to write this down, but if I had 2/3 equals 5/6, and I'm asking you, is this true? No, this is not true. We can double check this. 2 times 6 is 12. 3 times 5 is 15. That's not a true statement, so that proportion is not true. Every proportion, if it's going to be true, when you cross multiply, the left side ends up equaling the right side. So for this one, we want to solve for x. It is a proportion. Two ratios set equal to each other is a proportion. The way we solve proportions is by cross multiplying. So I'm going to multiply that side and cross multiply that side. So we end up with 42 times x is equal to 7 times 6. So we have 42x equals 42. So what does x equal? 1. All right, next one. So once again, we want to solve for x. Now that last problem, we could have figured that out in our heads. You know, what over 6 is equal to 7 over 42. That was pretty simple for us. But this one, there's no way to figure this out quickly in your head. So what we want to do is we want to set up an equation by cross multiplying. And on the left side, I'm going to get 5 times x. On the right side, do you all agree we're going to multiply 3 and that 4 plus x? But because that 4 plus x is not a monomial, because it's a binomial, it's bigger than just one term, I have to put it in parentheses. If you don't put it in the parentheses, you'll end up multiplying wrong. So that 3 needs to distribute to the 4 and to the x. So we are going to get 5x is equal to 12 plus 3x. And now we solve this. So I'm going to subtract the 3x on both sides. And I get 2x is equal to 12. So x will equal 6. Oh, I skipped the second one. That's okay. I'll go back to it. All right, letter B. Back up top. Well, how about you guys do this one on your own? Are we ready? So again, we want to cross multiply. So we should have done 4 times the quantity of x plus 2. Did we have to put parentheses around the x plus 2? Absolutely. That's going to equal 8 times 5. So I'm going to distribute in. We will get 4x plus 8 is equal to 40. 4x will equal 32, so x will equal 8. How many people got that? Perfect. All right, let's move on to some word problems. All right, on a map, 6 centimeters represents 16 miles. What distance is represented by 9 centimeters? All right, this first part on a map, 6 centimeters represents 16 miles. We need to stay consistent with this problem. That is the biggest mistake with these word problems. People don't stay consistent. So right when I read this, I'm going to decide, because we're talking about a ratio, do I want to talk about the centimeters to miles or miles to centimeters? I'm going to decide that my centimeters will be on top and my miles will be on the bottom. And once I decide, you could decide anything. You could have decided that miles was on top and centimeters was on the bottom. But once you decide, you have to stick with that the whole entire time. So they're saying 6 centimeters represents 16 miles. So I made my ratio of 6 over 16. That's going to equal, now it says, what distance is represented by 9 centimeters. Where should I put that 9? In the numerator or in the denominator? PJ. In the numerator. So my 9 centimeters goes on top. And they said, what distance is represented by 9 centimeters? That's what we're trying to find. So there's an X on the bottom. Before I cross multiply this, does anybody see anything I can do to make my arithmetic a little bit easier? Casey? You got it. Right here, the 16 over 16 can be simplified. So I'm going to get this to be, I'm going to divide top and bottom by 2. So we're going to get 3 over 8 is equal to 9 over x. I just divided this top and bottom by 2. So now we cross multiply it. And we are going to get 3x is equal to 72. I'm then going to divide by 3. And we get x is equal to 24. Yes, 24 miles. So 9 centimeters on the graph represents 24 miles in real life. Or in this real life word problem. All right, number 2. A car can travel 300 miles on 9 gallons of gas. So what's the ratio here? Miles to gallons. Miles to gallons. So I'm going to decide miles is going to go on the top and gallons will go on the bottom. So they're saying I can travel 300 miles on 9 gallons of gas. So it's 300 to 9. Can I, before I do anything else, can I simplify this? Yeah, let's go ahead. We will divide by 3. So I'm going to get 100 over 3. How much gas is needed to travel 750 miles? Where should I put that 750? In the numerator or in the denominator? In the numerator. So this 750 goes in the numerator. And how much gas is needed? We're going to put X on the bottom. So now we cross multiply and I will get a 100x is equal to 3 times 750. So we're going to get 100x is equal to 2,250. You divide by 100, you will get x is equal to 22.5 miles. Gallons, sorry. Okay. Down here. Okay, so once again, just to recap, a proportion is an equation stating two or more ratios are equal. We've already been through this. Anytime you have a proportion, there's actually names. So see how I have A over B is equal to C over D? So our first numerator is called the first term, sometimes also called the first proportional. First. Alright, the B is called the second term, also sometimes called the second proportional. C is called the third term, sometimes called the third proportional. And D is called the fourth term, also called the fourth proportional. And anytime you have a ratio, anytime you have a proportion, I should say, it's always the first over the second equals the third over the fourth. So your first term over your second term equals your third term over your fourth term. Now you don't have to write this down. It's going to come up later on. So I'm just going to go to the side. When you have your first over your second equals your third over your fourth. When you cross multiply, do you all agree your first gets multiplied with your fourth and your second gets multiplied with the third? Okay, just keep that in mind. When we cross multiply, the first gets multiplied with the fourth and the second gets multiplied with the third. That's going to come into play in a bit. Right, in a proportion, the product of the means is equal to the product of the extremes. This theorem is called the means extremes product theorem. All the means extremes product theorem tells us is that basically you are allowed to cross multiply. That's what it tells you. You are allowed to cross multiply. All right, we can skip this solving for x. We already did ones like that. Let's go to example 2. It says find the fourth term, sometimes called the fourth proportional, of a proportion if the first three terms are 2, 3, and 4. Well, just recall, it's always our first term over our second term equals our third term over our fourth term. And they're saying find the fourth term if the first three terms are this. So now we're going to plug this in. My first term is 2. My second term is 3. My third term is 4, and they're saying find the fourth term, so I will put an X there. We're going to go ahead and cross multiply, and we will get 2x is equal to 12, so x will equal 6. All right, next one. Are these proportions equivalent? The way we're going to check this, remember I told you, if you cross multiply and the left side equals the right side, then it's equal. If you cross multiply and the left side does not equal the right side, it is not equal. So let's go ahead and do that. Oh, I'm sorry. This is, we want to make sure they equal, everything looks the same once we cross multiply. So this is PQ equals RS. Right? P times Q equals R times S. So that's the first one. The next one we're going to cross multiply, and we get PQ is equal to SR. Well, is R times S and S times R, are they the same? Yeah, multiplication is commutative. It doesn't matter how you multiply them. So far, are we the same? Yes, so far we're good. These proportions are good. So the last one, we're going to have RS is equal to PQ. Is that the same as the other two? Absolutely. So are these equivalent? Yes. And our cross multiplication proves it. Okay. So these next two questions take a little bit more work. So it says if 10 times x is equal to 7 times y, find the ratio of x to y. Which one has to be on top when it says find the ratio of x to y? Jack? X. We need x on top. Now, a lot of people are like, oh, well, the 10 is with the x and the 7's with the y, so it has to be 10 to 7. That's wrong. So what we've given you is the cross multiplication. This is 10 times x is equal to 7 times y. I'm going to show you two different ways to do this. All right, first way. Since this is the cross multiplication, I'm going to put it back into a proportion. So I'm going to say, okay, well, I know my first is multiplied with the fourth, and the second term is multiplied with the third term, right? Isn't that what happens when you cross multiply? The first and the fourth get multiplied together, and the second and the third get multiplied together. And then we know it's always the first over the second equals the third over the fourth. So now my first is 10, so that goes in my numerator. My second is not x. What's my second? 7 equals the third term, which is what? Y, over the fourth term, which is x. I don't want y to x. What do I want? I want x to y. So if I want x to y, what do you think I have to do with the 10 and the 7? So since I flipped x and y, I have to flip the 10 and the 7. So it's 7 over 10. So the ratio of x to y is 7 to 10. Can I show you the other way? Are we ready? Bring it over here. So we have 10x equals 7y. Again, we need x over y. So I'm going to solve this algebraically. I'm going to manipulate this. How do I manipulate this? I need to get x and y together, and I need to get everything else over to the other side. So how do I do that? First thing I'm going to do we agree this is 10 times x equals 7 times y? I'm going to get the y, actually I'll get the 10 away from the x. So it was multiplied, we are going to divide. That cancels. So we have x is equal to 7 over 10 times y. How do I get rid of the times y? What should I do? Divide it. So what do we get? X over y is equal to 7 over 10. Do I care which way you do it? No. All right, let's do another one that's a little bit more complicated. All right, so it says, if this whole proportion, find the ratio of x to y. Right now, I have multiple y's, I have x's, I have a's and b's. So this is not a quick, this is not a quick solution. So what I'm going to do is I'm going to take this proportion and I'm going to cross multiply it. That's where I'm starting here. It's not much I can do within the proportion itself. So we're going to go cross multiply. We're going to get b times the quantity of x minus 2y is equal to y times the quantity of a minus 2b. I needed the parentheses. Now I look at this, is there any way to just get x's and y's together? At this point, no. So now I say, okay, well, let me just distribute in then. So we're going to have bx minus 2by, and I'm going to distribute in the y, equals ay minus 2by. When there's multiple variables, the rule is in algebra, you write them in alphabetical order. That's why on the left side I put the b's first, on the right side I put the a's and b's before the y's. Okay, does anybody see anything right now that would significantly simplify this? Only PJ? Abby? Good. If you add 2by to both sides, oops. If you add 2by, what happens on both sides? They cancel. So now we have bx is equal to ay. Now we can manipulate this and put it back into the ratio of, what was it? Was it x to y? Yep, now we can put it back in the ratio of x to y. How many people liked that first paired with the fourth way? How many people like the algebraic way? Guys, not only 2 people can, we need everybody to vote because that's how I'm going to do it. So this was the first way we did it. The first paired with the fourth equals the second with the third. How many people like that way? Okay, that's majority. So let's do it that way. So remember, this is b times x is equal to a times y. So this is the cross multiplication of something. So the first is paired with the fourth when you cross multiply, and the second is paired with the third. So now if we're going to put this back into the proportion, what is my first term? B. Good. What is my second term? A. What is the third term? And the fourth term? X. But go back, what was I asking for? The ratio of x to y. What ratio did we just write down? We just wrote down y to x. So to get the ratio of x to y, what should I do? Flip it. Flip them both. So the ratio of x to y will be a to b. All right, let's keep going. All right, definition. If the means in a proportion are equal, either mean is called a geometric mean or mean proportional between the extremes. What are the geometric means in the following two proportions? So, you know how we have a proportion, we have our first over our second equals the third over the fourth? Well, the numbers in spots 2 and 3 are called the means. The numbers in the spots 1 and 4, the first and fourth terms, they're called the extremes. So first and fourth term are the extremes, second and third term are the means. So this definition is saying when you have the same number in the means place in the second term and the third term, it's called a mean proportional. That's the name of it, a mean proportional or a geometric mean. So in letter A, what is our mean proportional? 4. In letter B, we don't know what it is, but we've represented it with the same letter, right? As long as it's the same variable, it represents the same number. All right, so find the geometric and the arithmetic mean between 3 and 27. The arithmetic mean and a geometric mean are two completely different things. Does anybody remember how to find the arithmetic mean when given a list of numbers? Does anybody know another word for the arithmetic mean? No? All right, the arithmetic mean, another word for it is the average. So how do you take the average of a list of numbers? You add the two numbers and then divide by what? By the amount of numbers we have. So I have 3 and 27. I add those and then I divide that by 2. So this is going to be 30 divided by 2, which is 15. All right, geometric mean is very different. Okay, the geometric mean is very different from the arithmetic mean. So for the geometric mean, what you want to do is you want to set up a proportion. They're asking us for the geometric mean, which tells us that spots 2 and 3 have to have the same number. That's the geometric mean, saying spots 2 and 3 have to have the same number. So the two numbers they give us, that 3 and 27, that's what you put in spots 1 and 4. So do 3 and 27. You now cross multiply. And what is x times x? Do not tell me 2x, please. What's x times x? X squared. And then we get 3 times 27, which is 81. So we get x squared equals 81. Now we solve for x. To undo a square, we take the square root. And I know you all know the square root of 81 is 9, but what else could it be? Square root of 81. Plus or minus 9. You have to account for the positive and negative number, right? 9 times 9 is 81, but isn't negative 9 times negative 9 also 81? Right, so you need to account for the plus or minus. That's a minus 1 point if you forget the plus or minus. You don't want to do that. Sarah?
Can you also write it like this?
Yeah, but then you'd have to solve that.
Oh, yeah. Okay.
So you can't just leave it as factors.
You can also do it like
Factoring, yeah, absolutely. Okay, I want you to do independence 1, 2, and 3 by yourself, and then we'll go over them. let's go over this. So we want to find the mean proportional between 14 and 16. So remember, the mean proportional is the same as the geometric mean. The geometric means that it's the same number and spot in the third term as it is in the third term. And the two numbers they give you, you put in the first and fourth. You cross multiply, you get x squared equals 64. X will equal plus or minus 8. All right, number 2, we have 3 times x is equal to 12 times y. And this time I'm asking for the ratio of y to x. That means I want y in the numerator. So if you remember, your first term is paired with your fourth, and your second term is paired with your third. So when you go back to put this into a proportion, it's your first, which is 3, over your second, which is 12, is equal to your third, which is y, over your fourth, which is x. So the ratio of x to y is 3 to 12, but what did I tell you? Proportions are, our ratios are fractions, and what should we do with fractions? Simplify them. So the ratio of y to x is not 3 to 4, it's 3 to 12, it is 1 to 4. All right, next word problem. 2 subangles are in the ratio of 3 to 5. So remember, supplementary angles make what kind of angle? 180, a straight angle. So I have a straight angle, and they're saying it's split into 2. So now they're saying the ratio is 3 to 5. The minute I take numbers out of a ratio, what do I have to put with them? X. So I'm going to have 3x and 5x. I need to solve for x. So what should our equation be? 3x plus 5x equals 180. So we have 8x is equal to 180, and it's absolutely okay that you get a decimal. That's not a problem. So when you do 180 divided by 8, you get x is equal to 22.5. But it says find the larger angle. So which one's larger, 5x or 3x? 5x. So 5x is going to be 5 times 22.5. So the 5x will be 112.5 degrees. I need to show you this stuff, but that could be part of tomorrow's lesson. It's fine. Okay, I will do this part of tomorrow's lesson, and we will stop here.